I am Ivan Michael Achanzo of Batangas State University, Bachelor of Science Information Technology, and for today's video, I'll be doing some activities in CCNA, routing and switching, specifically in Chapter 8, which is titled Subnetting IP Networks. I think there are 3 or 4 activities there. I'm going to look for them in the course index, and after that I'll be answering the VLSM. So let's start with the activity. Let's find first the activity here in the course index. So let's go to chapter 8. So here, chapter 8, let us find the activity. So here, the first activity is titled Calculate the Subnet Mask. So let's open it. The title is Calculate the Subnet Mask Basic. So the instruction is, in this activity, you are given a subnet mask in decimal format. Enter the binary representation of the subnet mask in the octet fields provided. Additionally, convert the mask and prefix notation format to the prefix notation field. So we are given a subnet mask, and we are going to answer the binary form of the subnet mask and the prefix notation of it. So we all know that 255 is represented in binary with 8 ones, because if you add 128, 64, 32, 16, 8, 4, 2, and 1, the result is 255. So let's put this 8 ones. I have tried to answer this from earlier. This 2552 and 248. So we're going to minus 7. So 7 is without the last 3 ones. So 1, 2, 3, 4, 5, and 0, 0, 0. Here the prefix notation will be, the prefix notation is how many, we can get it by counting how many ones we have used. So if, for example, here we used 8 here, 16, 24, and 5 here, so 29. That's 29. Let's check. Correct, you have successfully converted the subnet mask to binary prefix notation formats. Please click new number to continue. So let's reset and try another one. Here it's 255, so we're gonna use 8 ones again. 1, 2, 3, 4, 5, 7, 8. So 8 ones again. So 224. We're going to minus, I think, 255, 31. So minus 31, we're going to use the 16. So let's try plus 8 is 24, plus 4 is 28, plus 2 is 30, so plus 1 is 31. So we are not going to use, we're just going to use 3 ones from the start. 1, 2, 3, 3 ones, then the rest is 0. Here we're going to use 8 zeros. The prefix notation is 8, plus 8 is 16, plus 3 is 19. Let's check. Correct, you have successfully converted the subnet mask to binary prefix notation formats. Please click new number to continue. So we have answered 2 of those. Let's try the next activity. The next activity is from the next page. It's 8.1.4.5, and the title is Determine the number of bits to borrow. Instruction: in this activity, you are given the number of hosts that is needed. Hosts needed here. Determine the subnet mask that will support the number of hosts as specified. Enter your number in binary, decimal, and prefix notation format in the fields provided. So let's try to answer this. 25 8 ones. 8 ones again. Here is 8 ones again. I think here is 1, 2, 3 ones, and the rest is 0. Here, and here is, I think I'll just put 3 ones here because it's all needed in here. The ones here, let's just paste it. And here, I think it's 1, 2, 3, 4, 5, 6, and 2, 0. It's 2, 0. And here is, I think here 1000, the rest is all zeros. And here is, you put all ones here, and here 1, 0, and the rest is 0. After this, I'll be explaining how I get the answer. 1, 2, 3, 4, and the rest is 0. We use 7 here, 7 ones. And here, we use all 0. So, to get the subnet mask, we are going to answer the subnet mask. So, here's 2, 5, 5.25, 255.255.255.24. So I have answered this from earlier. I tried answering it, but my answer won't clear. It can't be cleared, I think. But I have answered this earlier, so I'll be just explaining how I got this. So here, the subnet mask, we get it from the binary. We convert this. We find the sum of 128, 64, 32, 16, 8, 4, 2, and 1. We add all of those, the answer is 255. Like here, it's 255. And here, 255. And if the answer is all zeros, we just don't put it here, just like this one. But we can also put it just like this one. And to get the prefix notation, we add, or we count how many ones that we have used in the subnet mask binary. So let's check this answer. It says correct, you have successfully determined the subnet mask and entered it in binary, decimal, and prefix notation formats. So we have answered that. Let's try to move to the next activity. Look at the coursing next. So here, 8.1.5.8, and it's entitled Practicing VLSM. Let's open it. There, it opened. Practicing VLSM. It has 2 parts, 2 figures. The instructions in Table 1, use regular subnetting to accommodate the network shown. Table 2, uses VLSM to further subnet network. Drag the addresses to the appropriate subnet description. So let's the first one, new subnet mask decimal. So I think this one is the new subnet mask decimal. And first, prefix notation. And this is the only notation here, the first prefix notation. First full subnet range, this is the first range. The second range is this, we do this one. The last subnet range is this. Let's check. Correct, you have successfully calculated the subnet. So let's look at the figure 2. The instruction here is Table 2 uses VLSM to further subnet the network. Drag the addresses to appropriate subnet description. So we have here the description, and we're just going to drag this. So second full subnet range /26 from table 1. So that answer that is this 192.168.564 to 192.168.5.127. New VLSM subnet mask in decimal is the subnet mask. This is the only subnet mask here. I think that is the answer. Number 3, VLSM prefix notation. The only prefix notation in this choices is this one. And first full VLSM subnet range 64 and 95, 192.168.5 to 192.168.5.95. So the last one is here. Let's check. Correct, you have answered you have correctly calculated the subnet using VLSM. So I have answered that activity correctly. So let's proceed to the next. So what I got here is a VLSM table. It has a subnet address, subnet prefix, first usable host, last usable host, and the broadcast address. So I given here is the first IP address 192.168.5.0 and the subnet mask 255.255.255.255.0. So here's the PCs. It has 5, 27, 11, 15. So we will fill this table. To fill that, we must first get the first IP address. So it is to get this, we first look at this number 5. So we depend it here. So we will add look at the left side and add this number 192.168.5.8. And from that, to get this, we will just subtract from here. So it will be 0.7 because 8 minus 1 equals 7. Then last usable host will subtract from here. It will be 6. 7 minus 1 is 6. And the first usable host is, we're going to just add 1 from here. So it will be 0.5.1. And to get the subnet prefix, we must look at the first here. It's 5. So here 5. And here it's not maximum from 8 and not minimum from 4. So it is placed here. Then by default, we just add from 24 because we will use all that numbers from the binary, the first 3, 24, 25, 26, 27, 28, 29. The subnet prefix is 29. Then we will add again, so it will be 192.168. Then 27, so 27 here, then this placed here. So we'll add 32 from 8, so it will be 32 plus 8 will be 40. So place 40 here, then minus 1 from here, so it will be 0.39. 39 here, minus 1 again from here, so it will be 0.38 and plus here, so it will be 0.9. To get the subnet prefix, space here, its base from here, so it's 27, so it will be placed here. From 24, 25, 26, 27, so here there's 27. Then we get the IP address, the subnet address again from here, so 40, so will be here. 11 will be placed here, so 40 plus 16 will be 56, so 0.56 there. Then minus to get the answer here, we'll minus it, we'll subtract, it will become 192.168.5.55. so we just subtract 1 from 56 from this, then subtract again to get this last usable host. We'll subtract again from here, so it will become 192.168.5.54. and to get this again, the first usable host, we'll just add 1 from its subnet address, so it will become 192.168.5.41. we just added 1 from the subnet address. Now to get the prefix, we will base here in 11, so 11 is in here, and we will just count from there. 24, 25, 26, 27, 28, so /28. Then we will get the subnet address of subnet 4. We'll just add again, so 15 will be placed here, so 56 plus 15 is 71, so it will be 192.168.5.71. then from there we'll just minus another, we'll just subtract 1, so 192.168.5.70. then the last usable host, we will subtract 1 again from its block address, so 192.168.5.69. then here in the first usable host, we just add from its subnet address, so 192.168.5.57. we just added from its subnet address, and from there the subnet prefix we will base here in the last number, it's 15, so 15 is around here, so we'll just count 25, 26, 27, 28, 28 again. And to get this broadcast address, I'll add 16 again in 0.71, because here it's 15, we'll base in 15 here, so 15 is here, so from we will add 16 to 71, so 71 plus 16 is 87, so 87. We will minus 1 to get the broadcast address. We'll subtract 192.168.5, so again it's 87, so it will be 86, and the last usable host will make it 192.168.5, then subtract from its broadcast address, so it will become 85. Then the last first usable host, to get it, we'll just add 1 from its subnet address, so it will be 192.168.5.72. We just added 1 from its subnet address. Now the last subnet prefix, I think it's just the same with the subnet prefix of subnet 3, because we just relied here, 15 here, so we just count from there, from 24, from the binary, all 3 groups in the binary, we use it also 24, and this is the 4th group, so we count 25, 26, 27, 28, so 28. So there, that is how you complete this VLSM table. I think I got all of it correct. That's it for the activities in chapter 9. So that's all, and thanks for watching.